Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. First thing I'm going to do is just draw the square out. And we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And a and b are the parallel sides. So these ones are the parallel sides. And the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence. So I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160. Take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend, but we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in 2s, so this will be 28, so the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing. It's timesing the x by minus 6. So we're going to divide both sides by minus 6. So that gets rid of the minus 6 on the left hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets, and we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. To answer this question, I'm going to do a quick number line. And I'm going to put the 12 meters on my number line. And I'm going to think what the next number down would be that it could have rounded to. Well, it's 10 to the nearest meter. So the next number it could have rounded to is 11. And to find the minimum it could have been before rounding to 12, all we need to do is find the halfway point between 11 and 12, which is obviously going to be 11.5. So our answer is 11.5 meters. To solve this, we've got to first of all factorise the left-hand side. And so we look at the number, and it's definitely a difference of 2 squareds. So x squared the square root of that will be x. And we think about what the square root of 144 is, which is 12. And so we plus 12 and we minus 12. So difference of 2 squares, you take the positive and the negative root. Now to solve, one of these brackets is going to equal to 0. So we're going to do the first bracket equal to 0. So we've got x plus 12 equals 0. And we're just going to put our lines down and take away 12 both sides. And we get x equals minus 12. So one of our solutions is minus 12. And we do exactly the same thing to the other bracket. So get it equal to 0 and solve. So add 12 both sides. You'll notice something about the numbers here, that they are just exactly the same. And that's because that when you find a solution, you get the number here and you just change the sign. So that becomes minus 12 and that becomes plus 12. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint, so our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. When something gets to the power of 4, you times it by itself 4 times. So we're going to do that to the x cubed here. So we've got x cubed times x cubed times x cubed times x cubed. Now when 2 powers of the same base are multiplied together, you add the powers together. So here we can add the 3, the 3, the 3 and the 3, and that will give us x to the power of 12. Now there is a simple rule here that we can use. Whenever you've got a power on the inside of a bracket and a power on the outside of the bracket, all you need to do is multiply them together. 3 times 4, which is 12. So we're asked to find angle BCE, and that is going to be this one here, because you start at B go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the two 79s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B and then draw an arc from B, And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you, because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the two lines join with where the two arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So we notice with the simultaneous equations, we've got the coefficients of the x and the y's different. And I always focus on the y's. So I'm going to make the y's the same. And there's no reason you couldn't focus on the x's and make the x's the same. It's just I tend to always focus on the y's. So what I'm going to do is figure out what 3 and 8, so I'm ignoring the signs, what's the lowest common multiple of 3 and 8, so what's the first number in both their times tables, and that's going to be 24, so I need to make them both 24. So I'm going to write out the first equation, so 2x minus 3y equals 12. Get my lines in, and I'll notice that I'm going to times everything by 8 to make that y, the coefficient of the y, to be minus 24. So we got 16x minus 24y, which is good, that's what we wanted. And then we're going to do 12 times 8, which is 96. Going to write the second equation, so we've got 3x plus 8y equals minus 7. And this time I'm going to times everything by 3. And so we've got 3 times 3, which is 9x, plus 24y, which is good, that's what we wanted. And then minus 7 times 3, which is minus 21. So I'm going to write these out again. So 16x minus 24y equals 96. And 9x plus 24y equals minus 21. So with simultaneous equations, we're working downwards. So I'm just going to show that with circles. Make sure the signs go with the y's. And we're either going to add or subtract to these. I'm just going to make that more clear. That's 96. And to know whether we're going to add or subtract, we look at the one we've made the same. So with the y's, we've made the same. And we look at the signs. If the signs are the same, we're going to subtract. If they're different, we're going to add. So S in the same is S in subtract. The D in the different is the D in add. Well, looking at them, they are different because the first one's a negative 24, the second one's a positive 24. So we are going to be adding. But we're not just going to add those, we're going to add all of them going downwards. So we're going to do our kind of sum line, and we're going to add going downwards. So 16x plus 9x is 25x. Minus 24 plus 24 is going to be 0, which is good. That's what we wanted. We want to get rid of the y's. And then we've got 96 plus minus, so effectively minus 21, which is 75. Do a quick solving by dividing both sides by 25. And we've got x is equal to 3. Now we know what x is, but we've got to find out what y is. So what we're going to do is substitute the value of x into the first equation. So we've got 2 times 3 minus 3y equals 12. Well, 2 times 3 is 6, so we're going to take away 6 both sides. And we've got a minus 3 as the coefficient there, so we're going to divide both sides by minus 3. So we've got y equals minus 2. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and a small triangle. We can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, well, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as x, then the sport will be 2x. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2x, take away the 11 that we already know about. And the painting is the same. We know the whole thing is x. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be x minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So x minus 11 plus 11 plus 2x minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. I'm going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent, so we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two, so it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in, and we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29, and we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79, and that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. So the first thing I'm going to do is I'm going to look at the coefficient of the x squared, look at the number on its own at the end, and I'm just going to multiply them together. So 11 times 6, which is 66. And 66 is going to be quite a useful number, because what we're looking for is two numbers that times together to make 66. And we're looking for the same two numbers that add together to make the coefficient of the x, which would be minus 25. Now, something we know about these numbers straight away is they must both be negative, because they sum together to make a negative, but when they're multiplied they make a positive. The only way that can happen is if they're both negative. And so what I'm going to do is I'm just going to look at 66 and I'm just going to write all the factors of 66, but we know both of them must be negative. So it'd be minus 3 and minus 22, and then minus 6 and minus 11, and then the rest will just be the other way around. So when I add these together, I'm going to look to see which one adds together to make minus 25, which is actually going to be this one here. So our two numbers are going to be minus 3 and minus 22 that we're going to be using. Now it seems like a lot of effort so far, but there is wisdom to this, because what I'm going to do now is I'm just going to rewrite this but instead of minus 25x, I'm going to split it up. So I'm going to split it up into minus 3x, minus 22x. There's the minus 3 and the minus 22 that we've just found, and then plus 6. Next step is I'm going to factorize this linearly. So I'm going to do this one, and I'm going to do this one as two linear factorizations. So I'm just looking at the purple box, and well, there's no numbers I can divide out of both of them, but there is an x. So this will be x brackets 11x minus 3. Now we've got a bit of a weird situation here, because you'd think that it would be 2 that we divide out of both of them, but it's actually going to be a minus 2 because there's a minus there. So it's going to be minus 2, and then we've got 11x plus 3. Now notice what we have here. We have a repeating bracket. Both of these are 11x minus 3. And I've made a mistake there. Let's just quickly correct that. That should be minus 3. And I was just about to say, if they're not matching, it means you've done it wrong. The mistake I made there was minus 2 times positive 3 would not give us the plus 6 there. It would give us minus 6. So that needs to be a minus 3. So there's a repeating bracket there, and that is actually one of our answers. And the bit that's left over is an x and a minus 2. And we actually put those together to make a second bracket. And so our answer is x minus 2, 11x minus 3. Or the other way around, you could have 11x minus 3 brackets x minus 2. When solving simultaneous equations graphically, the solutions are just where the two graphs meet. So we've got y equals x plus 4 drawn, and we've got y equals x squared minus 2 drawn. So the solutions will be here and here. So the coordinates will be x equals minus 2 when y equals 2, and x equals 3 when y equals 7. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realising is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know. So the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So when we have two equations that are both linear, we obviously do solving through elimination. But here we've got a kind of quadratic-y, kind of circular graph on our second one. So we're not going to be able to use the method of working downwards and eliminating the x or the y's. But here what we can do is we can solve through substitution. This first thing says that instead of y we can write 5x. So what we're going to do is just write out the second equation, but instead of y we're going to write 5x. So we've got x squared plus, and instead of y we're going to write 5x, and we're going to put it in brackets because we're going to square it, plus 10x equals 111. So we can actually create a quadratic from this situation. So we're going to just square that. So that's going to be 25x squared plus 10x equals 111. I'm going to just put our solving lines in. It's not much solving to do, because all we need to do is take away 111 from both sides to get it equal to 0, which we need to be able to solve the quadratic. So x squared plus 25x is 26x squared plus the 10x, and we're taking away 111 from both sides, so So that will equal 0. So looking at the question, it says 2 decimal places. It's a calculator question. Chances are we're going to be using the quadratic formula. So for the quadratic formula, we need to find out what a, b, and c are. A is the coefficient of the x squared, which is 26. B is the coefficient of the x, which is 10. And c is the number on its own, which is minus 111. So we're going to substitute those into the quadratic formula, which is x equals, and then we put our fraction in, and we've got minus b, and I always put them into brackets, plus minus, and you'll see why if you ever have negatives, so you can get in real problems when you have negatives. It doesn't take much longer to put them into brackets. Minus 4 times a, which is 26, times c, which is minus 111. And then all of that over 2 times a, which is 26. So we're going to do this once with a plus there. And so when we have a plus there, we get 1.882, blah, blah, blah. And when we do it with a minus there, we get minus 2.267, blah, blah, blah. But the problem is those are x values. And when we solve, we've got to also find out what the y values are. Well, we actually have a really nice way of finding out the y value, because if you look at this first equation, it says that y equals 5 lots of x. So all we need to do is multiply these x values by 5. So we're going to times that first one by 5, and we get 9.414, blah, 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 times the second solution of x by 5, and we get minus 11.337, blah, blah, blah. And so when we round those to 2 decimal places, which is what the question asks, we can have 1.88 and 9.41, and we have minus 2.27 and minus 11.34. Okay, so we're given the fact that this is a graph of y equals cos x, but it also says that we're looking for solutions for cos x equals minus 3/4. So if you look at those two things, you'll realise that y equals minus 0.75. And if we plot that on our graph, and it's a bit of an estimate, it doesn't have to be perfect, you can see that there's 2 points which it crosses the graph. Okay? Now, we need to work out what one of these points is, and the way we do that is we do the inverse cos of the minus 0.75, and we do that on a calculator, 138.590, blah, blah, blah. Now the problems with calculators is they will only ever give us the first solution, so this solution here. They can't give us all the solutions because there are infinite solutions, because this graph is going to go on forever, waving up and down, okay, and crossing that line which we've drawn in blue on the graph. So it gives us the first one. The calculator will always give us the first solution, but we can use symmetry to find the next solution. If you look at the graph, we've got this point here, and the whole graph, if I draw a line up, the whole graph is symmetrical. Okay? Do you see it? The whole thing is symmetrical. So if the distance here, so the distance between the start and here is 138.590, blah, 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 then that distance must be the same distance as here. That must also be 138.590, blah, blah, blah. So to work out what this coordinate is, all we need to do is 360 take away the 138.590. So 360, which is here, take away this bit here that we know, and that will tell us what this bit here, what this coordinate here is. And so we've got, type that into the calculator, you get 221.409, blah, blah, blah. We want the answer to 2 decimal places, so the first solution is 138.59, and the other solution is 221.41. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. So we have the original y equals fx shown in the graph. And it says it has a minimum at 1 minus 1, so it's this one, it's the black line here, and we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. We're going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here, and let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tram lines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. I'm just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5, and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tramlines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimeters. So the angle we're looking for, if I just draw a line here, the angle is HEG, which is this one here. So I'm just going to call this X, and what I'm going to do is I'm actually just going to draw out the triangle in a 2D way. And I'm just going to use this one. There we go. So we've got E down here, H and G. We're looking for this angle here, which is X. And we're given the fact that this is 14 and this is 12. And so what we're going to do is obviously use trigonometry because we've got a right angle triangle here. So the first step is to label the sides. So hypotenuse is opposite the right angle, opposite is opposite the marked angle, and adjacent is between the right angle and the marked angle. And next I'm going to put my triangles in, and those are going to be So, Ka, Toa. Well, if you look, the H does not have a number or letter next to it, so we cross that out, and so we're looking for the one without the H, so that's going to be Toa. Toa is short for tan the angle equals the opposite over adjacent. The angle is what we're looking for, so I'm just going to call that X. The opposite is 12 and the adjacent is 14. Get my solving lines in because we're going to do the inverse tan both sides. And so we've got X equals the inverse tan of 12 over 14, which is 40.601 blah blah blah. And 2 decimal places, that will be 40.60. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.